So I'm going to talk today about NetFlow. And NetFlow is the primary input of information into Profiler, which Boris talked about this morning. Comes into Profiler, we do a lot of analysis, network-based analysis for visibility, alerting, all that kind of stuff in your network. So I'm going to tell you what NetFlow is, what it's good for, and how it differs from packets. So NetFlow data collection. This is all about collecting reports from throughout your network on what's going on in your network, what data is passing through what points in your network. So it's all about visibility. And the nice part about NetFlow is that we're talking about end-to-end visibility, as opposed to one of the things I like to point out is that packet capture. To get packet capture, you need to put a probe there. With NetFlow, you pretty much probably already have support for NetFlow in your network. The switches and routers are actually delivering data. So I'm going to describe what is a flow, how does in the context of NetFlow collecting, what exactly is a flow, what inside is it. Talk about observation points, these are places in the network that will collect flow. What does the flow record really look like, and how do devices export it? And then on the other side, after it's been exported, flow collection. Who's collecting flow? What can you do with flow? And skip that last piece and pull that out. So what is a flow? A flow is a set of ID packets that share a common set of attributes. And that kind of sounds pretty generic, but it's kind of meant to be that way. NetFlow goes in a lot of different directions. By and large, flow is defined by the 5-tuple. Everybody knows the 5-tuple. So source and dest IP, protocol, and the source and dest port. And I'll point out one thing. It is source and dest IP and not client server. What does that mean? It's unidirectional. So TCP conversation will typically be two flows, one in one direction, one in the other direction. And one of the reasons that's important is for things like asymmetric routing. You'll see your router may report half the flow and not the other half. So this top piece, the 5-tuple, that's the pretty typical definition. You actually could go on to switches and routers and configure a different flow definition and say, you know what, that generates way too much information. Because this is particularly when one of these ports is the client port, you end up with just more information than you can really handle. So you could conceivably drop it down to this, in which case the records will have a lot more data per record, you get a lot fewer records, and you get a lot less visibility. And in general, we really don't see this too much. It's just, I kind of throw out there as it is possible. So observation points. These are the places in the network that NetFlow is collected. So this is important because the same flow is going to traverse your network. It's going to go across multiple observation points. You've got client going through a router, going through a firewall, going through another router, and so on. At each of those points, at each of those devices, there's observation points where you can be, watching that flow. This is kind of like standing on, if you're traveling from Boston, out to San Francisco. You've got someone standing in St. Louis, you've got someone else standing in Kansas City. Those are two different observation points for all the traffic going between Boston and San Francisco. So it's also important to note that you can actually have multiple observation points within the same device. Ingress port, egress port. Sometimes some devices you can even do it on either side of processing, like this sort of processing within the same ingress interface. So you could get, many, many observation points. Generally, we see either just one per device or maybe two per device. So as the flow is going across the network, you're going to see different counts. And this is one key, key information point about NetFlow is that you're going to get different counts, and this is because you have different bytes. The router closer to the source is going to probably see higher byte counts than the router at the end because of packet loss. Retransmission will cause that first device to say, oh, I saw 200 packets. The device closer to the destination will only see 100 or so. Ingress flow versus egress flow. This is coming up more recently because of NetFlow 9, which I'll talk a little bit about more later. But this will help you track what came into the device versus what left the device for this flow. Helps you identify queuing problems. We saw 1,000 bytes come in, but only 900 came out. That's because 100 bytes were blocked or redirected or something. All right, so here's an example. Go ahead. Client laptop talking to the server over here, going across two routers and the main cloud in the middle. Conceivably, we've got 4 observation points: ingress, egress, ingress, and egress. So we can have, from this network, if we turn on NetFlow, export at all these devices, you could get, for just one conversation, you would actually, just for the unidirectional flow from client to server, you get 4 flow records. Client sent 1,000 bytes. 1,000 bytes were reported by this guy. 1,000 bytes coming out. When we crossed the WAN cloud, we had some packet loss. This guy says, only 800 bytes. And then there's some queuing loss inside this router, so only 750 bytes actually got delivered. And you notice we actually don't have visibility to how many bytes were received. This may have been less than 750, unless you've got a probe or something very close to the actual server. You lose a little bit here, but this is pretty good. So here you've already learned that you've had some loss across the WAN. And if you really look, you'll see there's some loss within the router itself. So flow record. The first piece is the flow key, and this is like a database key. These are the unique fields that are going to define what is a record. And this is, again, the most common is just the 5-tuple. So you'll see this all the time. You see flow records, you look at the 5-tuple, and we go from there. It's usually configurable. I think you can actually configure it based upon byte offsets if you want to go to that level of detail, but not easy. Beyond that, you've got the flow key, and then you've got all the information that you're gathering about a flow. So you've obviously got the flow key values, the IP addresses, and so on. You have bytes and packets. This is probably the most common. You've got some other stuff like what ingress interface did it come in on the router? Because again, for one flow record, it came from one router in the network. So router 1 says came in on interface 1, left on interface 2. 7,000 bytes, 50 packets. And then some other information you might get, QoS tags. This is getting pretty interesting as well with VoIP being released, other QoS policies you can see, and you'll actually get QoS tags, one for the ingress and one for the egress, so you can say, look at that, the QoS changed. It came in at default, went out EF, or it came in EF, worse, went out default. So metering. This is kind of the IETF term for how are we generating these flow records. It's the process of generating flow records by observing the traffic at some observation point. So here we've got a bunch of packets coming into the router. We're talking about this observation point right here on the router. And here we've got a metering process. And this process, what does it do? It takes the packets in. This is, it's snooping on the packets. It's not actually in line, so if this metering process overloads, it's not interrupting traffic at all. It's just watching the traffic. As it watches the traffic, it's updating the flow cache. This is usually, a pretty lightweight process. Some devices are better than others, particularly if you look at some of the older devices. You turn on NetFlow, this may bog things down. Sometimes, in Cisco devices, there may actually be 2 levels of flow cache, one for the fast path and one for the slow path. But in general, the concept is the same. You can count packets and bytes and packets and other things, create a flow, put it in the flow cache, and then periodically, there's the exporting process. What does it do? Takes records out of the flow cache, sends them out on a wire. This is, we've configured to say, collect flow records and send them to some device like, Cascade Profile or some other NetFlow collection device. This is what a typical NetFlow record looks like. This is like the base standard. NetFlow 5 is when things really got interesting. This used to be about the most dominant deployment. It probably still is. And it's a static structure, fixed size. Okay, your exporter IP address, this is the router IP address that's one of the interfaces that's exporting. This is your 5-tuple bytes and packets counters. You've got the bit mask of all the TCP flags that have been seen. These are the 2 interfaces. So it came in on interface 1 on the router and left interface 2. QoS tag was default, and then timestamp. So when the first of those 29 packets, the first one came in at this time, the last one came in at this time. So it's a pretty nice snapshot of what's going on with the flow in the network. So when are they exporting? So we've got the flow cache, packets coming in, the metering process is taking those packets, counting them up, putting them into the flow cache, and then the exporting process is pulling it out. When does that happen? A couple of cases. Flows terminate. Pretty easy. You see the pin go back, back and forth in both directions. You leave it in the flow cache for just a little bit longer to make sure there's not some extraneous pins or fin hacks coming back. And then you say, great, I want to clear out my cache, send that flow. inactive flow timeout. This is the flow. It's hasn't been closed. We haven't seen anything or a reset, but it's been a while. Haven't seen any traffic. I don't want to waste space. Router has limited memory, limited flow capacity. So let's. And this is typically something like 15 seconds. So you start a TCP connection. If it sits idle for 15 seconds, they'll send a flow record and say, hey, in there, the flow was only active for 2 seconds. 15 seconds later, we'll send an update saying, here's what I saw. Active flow timeout. This is critical for getting data in a timely manner. If it's a long flow, mail connection to the exchange server is open for maybe hours. Every 60 seconds, if the flow timeout is set to 60 seconds, every 60 seconds, the router will send us an update on that flow. Say, in the last 60 seconds, here's what I saw. And it's always an update. It's not cumulative. In fact, whenever a flow is sent out by the router, it's wiping its memory as if he never saw that flow before. So the next packet that comes in will then cause a new flow record to be generated in the flow cache. And then last, force flow discard. You overload the router, its flow cache has only got 1,000 entries in it. If you see 1,001 come up, we'll toss one out to create that new flow record. Could be with LRU, random, could be any number of schemes. So the interesting thing here is, again, these are this is all in the router that's happening in memory. So is it possible to have multiple flow records on the same observation flow? Yes. Long-lived flows, so I mentioned that, long-lived flows every 60 seconds we'll get another flow record. And have the same file tuple, but the data values will all be different. Each flow record in that case is an update. So the flow key is identical, the bytes packet counters are an update. So now what's the mechanism? How do we send flow across the network? Configure an IP address, target IP address in the router is pretty simple. The most common, UDP. Just a standard UDP. There's no reliability, flows can get lost in transit, but it's a very simple process. You can stuff about 30 records if you really wanted to per UDP packet. So you get 30 records per packet, sent via UDP, and then just shipped off, and it's nice and lightweight. UDP is chosen because it's lightweight. This is a process that the routers and switches are doing constantly. More recently, they're adding SCTP for IPFix, which is the standardized version of NetFlow that's coming out of the ITF. So it's a continual process. This is you turn on NetFlow on your router, and you put Wireshark on that router, you're going to see flow all the time. And it's not like, when the conversation finished. No, you'll see it, and it's not like they're batched together. It's not a big batch once a second or a big batch every 60 seconds. This is, on the time scale of when the flows started and ended. So again, continual process. Here's an example. You'll notice here, start time. This is when the first packet for this flow was seen. This is the end time. Typically, you'll see that the start times bounce around. The end times are sequential. And this is because the flow is generally exported in a sequential order based on when the last packet was seen. You get the source address, the destination address, the protocol. There's the 2 ports involved, bytes packets, and the TCP flags. Point out a couple of interesting examples. Here you can see this represents one TCP connection. The source and dest are swapped. Here we can see this. Based on this, we can already tell that this was a complete connection from SYN to FIN. The other side SYN to reset. So we already know that this was an entire conversation that started at 8 o'clock in 15 seconds and terminated at 8:01 in 14 seconds. Well, we actually, more data came across. So this is it. I actually should have, I meant to combine this, but this is an example of what would happen if the flow continued. A minute later, this is about a minute later than this, you see an update. Exact same file tuple, an update with more packets, bytes and packets in the file. You see some ICP in here, there's UDP, so any IP protocol will fit in here. Updates to IPFix allow IPv6 to be sent as well. So IPv6, actually I'll talk about the additional versions in a bit here. So what devices export flow? Most devices in the network already are doing this. Routers, Cisco, Foundry, Bay Network, just about any flavor these days is sending some variant of NetFlow. Switches, we've got switches sending NetFlow. Riverbed steelheads, nice part about steelheads, they send NetFlow. In fact, they give us good data. This is when ingress and egress becomes important. Ingress tells us what the byte counts were before optimization. Egress tells us what the byte counts were after optimization. Then we've got flow there. Our cascade sensor sends a variant of flow. Packeteer sends us flow records. So various ways to get flow information throughout your network. So often you can turn on NetFlow in your box. You can download a freeware version of a NetFlow collector out there. It's going to pull in flow. You can already start running reports to see what's going on in your network. NetFlow 5, probably most widely in use, supported by most vendors. Fixed flow records, or the record itself is fixed in size. The packet has multiple records. You can put as many records as you want into it, as up to the MTU size. Pretty good format. Gives you a lot of information. Moving up to NetFlow v9, much more complex record format. It becomes templated. I'll show you an example in Wireshark. It allows you to have a lot more information. Now, once you're on the router side, you can configure. I care about bytes and packets, but I also care about these other metrics. Or I want D-link tags. I want various other information, ASA, IDs, all that kind of stuff. But by and large, bytes and packets from the NetFlow 5 are what would get exported into V9 as well. And this is when they first started actually supporting ingress and egress flows. There's some of this in V5. You can get ingress and egress out of some of the Cisco flow records, but in V9 you actually have a field that says, yes, this represents an ingress, this represents an egress. And now IPv6, sometimes known as NetFlow v10, the working group, ITF working group has done a good job here. They're really expanding on, it's pretty much the same format as v9, some minor tweaks, but a lot more fields. And they keep adding more fields, and they've got space in there for router vendors or vendors to put their own type of data in there. So it could be proprietary data, or it could be data that they want to share that anybody could use. JFlow Packeteer. This is very close to NetFlow, but JFlow from Packeteer is both of those. We pretty much take those in Profiler just like NetFlow. We just normalize it all. The byte counts are pretty much matched up. SFlow, interesting. This is kind of similar. If any of you are familiar with SFlow, SFlow is sampled. So the premise there was, instead of sending actual flow records like NetFlow does, it instead sends samples of packets which contain very much the same information. You've got the 5-tuple header, you've got a byte count, packet count. If you know the sample rate, you can statistically scale that up to find out how does that relate. What is the aggregate behavior on whatever device that is. And then sensor flow. So one of the interesting things when you start to put additional devices like our sensor probe, you get stuff like layer 7 application tag. Our cascade sensor does DPI. We're looking deeper into the packet. It's a standalone device. It's not versioning the router at all. Therefore, we can do that. Out layer 7 application tag, we get performance metrics like network round trip time. We can count TCP retransmission. We can pass all of this along, and then it becomes part of the flow record that then Profiler can use that in addition to what the routers and the switches out there are. So this is a network diagram of what this all looks like together. We've got a cloud of devices, miscellaneous clients and servers. We got these three routers. You configure NetFlow on all three of them. You point NetFlow from these guys to the flow collector's IP address. And as soon as you do that, these guys just start streaming. For whatever conversations they're seeing, they're going to send you NetFlow records. And it's now up to the job of the NetFlow collector to take that data in and do something interesting with it. What are you going to do with on a NetFlow collector? Logging. This is probably one of the most basic functions. Take all that data in, kind of like a sniffer. Instead of packets, we're logging flows, putting them to disk, time sequencing them so that you can now go back and do reporting on them later, whatever you want. And because these are smaller, right, you've got one record as opposed to multiple packets for a single flow. Much smaller, much more condensed. You can store years if you really wanted to, depending on your network. So then reporting. Go back onto those. This kind of comes in two flavors. One is reporting on the NetFlow packets as they come in real time. The other is being able to do historical reports. Go back in time and say, oh, I've been collecting NetFlow for 2 weeks. Show me the time graph of what this server has been doing over time. You can get all that information pretty easily from NetFlow. And then that leads to reporting. Now I can say, you know what? That server, I didn't expect it to be doing 1 megabit of traffic, so we can set alerts. And Boris alluded to some of this. We do analytics based on NetFlow. We take all this data in, we can build baselines of what we expect a given interface to be sending over time, you know, taking weekly seasonality into play. We get all that information just from watching NetFlow packets coming in. So I talked about collecting multiple flow records from the same observation point. What about getting them from different points? I mentioned multiple routers. If we go back in this picture, one flow from here to here, we'll get NetFlow records from this router and NetFlow records from this router, talking about exactly the same flow. So what do you do? What's the point of that? So each device is going to send a unique flow record that's going to have the same 5 tuple. Key is to pull those flow records together, collate them, take advantage of the fact that we can match them up by the 5 tuple. They both match the 5 tuple, and then keep track of the fact that each device is sending different byte counts. Timestamps are slightly different. You know, and then you can combine this with sensor, which is telling you layer 7 information. You now can correlate all of this together and say, for this flow, I know end to end, router 1 had 1,000 bytes, router 2, 800 bytes. The sensor tagged it with, you know, this is a Webflow web application, maybe it's Salesforce.com. You can put all that information, and it's now one complete record, allowing you to report on what happened on router 1 based on information you learned elsewhere. For example, you could say, show me all the flows that came into router 1 using EF as a tag, but then got to router 2 and the tag is now default. You can only do that if you start to correlate these flow records together from all points in your network. So these are kind of what routers are involved in the client in San Francisco connect directly to the database server. How do the byte counts change as the flow went across the network? Was the QoS consistent? So I'm going to compare to flows versus packets. What's the advantage of flows? What are the advantages of packets? I'm going to talk about queries, data storage, and visibility. So supported queries. Here's the kind of thing, just a random collection of the kind of things we can do. With queries, inter-packet timing analysis. Key. Han Sang gives us does this every year. He shows some excellent examples of look at the delta between packets. You can't do that with flow because you don't have the packets. You need packets for that. TCP window size problems, SQL transaction time, any of this stuff where you're looking at stuff that happens within one flow on a per packet basis. You need packets. But let's take a look at some of the other things that are pretty common. Off host pairs in the network. Who are the most chatty? What clients are connecting to this external server? How many connections are there going through this particular router interface? And link congestion events. I want to know why is this router so congested? What server ports are in use that are causing, which ones are consuming the most bandwidth on this interface? You can get all of that combined with packets workflow. And notice, in order to get the packets, you need to have a probe deployed there. With NetFlow, you just go to the router, configure NetFlow, and you're off and running. So here's an example with flow. Here's just kind of a smattering of the kind of things you can do. Here's all the stuff you can filter on. You can run reports and say, I want to restrict it to this list of hosts. I want to, maybe I just want to say just, connecting to this particular server. What's the client port? What's the server port? Any of this. You can mix and match all these criteria just like you can the DPF filter going into TCP line. This restricts what your report's going to be like. Your output, you can say, well, based on this, show me all the hosts involved, or show me the host pairs, or what devices did this set of hosts use when connecting to the server. All this kind of information is the output, and then what kind of data column can you get? You can get, right now, Profiler, just based upon NetFlow information, we have something like 800 data columns, and some of them are kind of variants of each other, like transmitted bytes and received bytes. But the amount of information you can get is just, it's almost data overload. You get to the point where you've got so much data. So if you were to go to packet level, you've even got more data. So you can get pretty much anything you want from the conversation level with NetFlow. Data rates and storage. So take a 100 meg link. If that link is fully utilized, 100 megabits a second with packets. NetFlow, usually about 1 to 2%. So I went on to make the pessimistic side says it's 2%, so 2 megabits a second. So data retention, I've got a 1 terabyte disk, and I'm storing packets. I'm going to get 1 day of storage. I'm going to roll over in 1 day. 2 months of flow. So just right there, now having done nothing but log this stuff to disk already, I've now got 2 months of historical logs where I can go back in time and say, oh, what did the server do last Tuesday? I saw the server today seemed like it was having a problem, but last Tuesday, was it also seeing the same amount of traffic? Because if it was the same amount of traffic, that's probably not my culprit. It helps you identify where do the patterns start, when did problems crop up. If you have packets, you're going to be limited by this 1 day of disk. Talk about query times. This was kind of one of the big drivers. In order to query over the last hour, I need to scan 50 gigabytes of data on the disk for packets just to answer a query like top host security. With Flow, I can scan that at just 1 gigabyte. So right there, that 50-fold increase in speed. So what could have taken you 15 minutes to run a packet-based query takes you less than a minute, or 20 seconds to run the same query based on Flow. So you start here. When this doesn't work anymore, you go to packets. But starting on packets, you're going to burn time just sitting here waiting. Visibility. I've talked about this a lot already. Packets, you need to install pros at each location that you want visibility. If you're lucky, you've got devices out there where they support some variation of TCP dump already, but you're not going to leave it on full time, so you get spotty visibility on demand. You have to then not only install it, now you've got to configure a span, you got to wire up to it. NetFlow, you install one collector somewhere in your network, probably your data center, and then for every place that you want visibility, configure NetFlow. Just a few commands on the router and you're done. Point at the single collector, there's no wiring done. Once you've installed this collector, there's no more hardware involved. So analysis with flows. What do you get? You get historical reporting, you get trending, alerting, you can diagnose a surprising number of network problems based on NetFlow only. You get fast queries, you get broad visibility across your entire network, and you can identify who's involved in the problem. What host was called, what network was slow. Let's talk about who's the host that's consuming the most bandwidth. That's a question that's ideally answered with NetFlow. And then once you say, well, now I know this host is involved, you can start to dig a little bit further. You can still with NetFlow what clients was talking to that server at that time. And then you can finally narrow it to one host pair and say, great, I haven't figured out what the problem is yet. I know who's involved. You can either go walk over to the guy's desk and say, what are you doing? This looks like you're doing BitTorrent traffic, or dive into packets and you can get further through. So the key is narrow your focus with NetFlow and then dive into packets. There we go. So any questions? Yeah.
During your dedupe, I know the profile, I guess the profile is deduplication.
Yes.
Of the various flows it receives across the devices, how does it know which packet count to keep, or does it keep all of it?
Profiler keeps all of that. So there's some careful timing considerations to be done, mostly because for long-lived flows, those flows are going to get chopped up into 1 minute boundaries or maybe less. So we put a lot of effort into trying to synchronize those. But we keep all those packet counts. So when you report on a flow, if you don't specify what router you're interested in, we're going to tell you the maximum count. Because well, router 1 was closest to the source. It had the highest byte count. When you ask for this flow, we'll tell you 1,000 bytes. But if you say, listen, this flow, but only from a particular device, we store all that information and we can tell you specifically what the byte counts were on that device. Any other questions? Yes?
Once you fill up your storage device, does it overwrite the data, or do you have to go in and clear it out?
Yes, it's a big, so we structure our flow storage in its fixed size, and so depending on how fast flows are coming in, that will overwrite sooner. So it's always fixed size, and in fact, we go from flow records, which are 1 minute, and give you 1 minute granularity. We have 15 minute granularity, which takes those 1 minute buckets into the, reduces the amount of information in 15 minutes, and then we have 1 hour, 6 hour, to give you, you can resize those partition sizes and think how much visibility you want. So, in general, what we have is your flow storage goes back about 2 to 3 weeks, and then 15 minute storage will go back maybe 2 months, 1 hour storage will go back 2 months, and so on. So that when you use 1 hour logs, you mostly want to use 1 hour logs because you're doing a long report, you're doing I'm doing a quarterly report on what happened to my network over the last quarter. You don't want to go to 1 minute logs because you just don't need that granularity. You can't graph that kind of data anyway. Plus, your queries will take a lot longer. So we have staged granularity. So in all of that, you can add disk. You get whatever storage requirements you need. Good. Thank you.
Yeah, one here.
Oh.
Can you talk about best practices with scaling?
In the context of our product set, or in the context of
both general and your product set.
Yeah. So
What was the question?
So the question is asking about scaling. What are best practices for scaling? I mean, just like with packets, you can overwhelm yourself with data. In large networks, you can overwhelm yourself with NetFlow. And you can turn on NetFlow at every switch and router along the path. In your client going to server, you could have 20 devices sending you NetFlow. Usually we talk about where are your choke points. Send NetFlow only from places where like WAN routers or routers at the edge, and then key switches or close to the server, close to the client. But stuff that where you don't expect there to be a lot of losses just with the additional devices. We tend to say it's up to you. But in terms of scaling, if you've got more and more flows, Profiler scales up to millions of flows. We can support millions of flows, which is a pretty large network. There's additional types of scaling. I mean, because flow records are on a per conversation basis, just because you have a lot of network traffic doesn't necessarily mean you have a lot of flows. If you have a lot of long flows, you're not going to see a lot of flows. But if you have, even in a small network that tends to be very chatty, very small, short-lived flows, you'll see a lot more flow storage. So we have some guidelines on how to size how big of a profiler do you need, how much disk space do you need, based on how many clients are in your network, how many servers, how many applications do you typically run, how many routers are in your network. So they kind of all come into play. A typical, a small network will be about 85 to 10,000 flows per minute, and that's we're talking maybe 50 people. That's pretty small, and that includes traffic out to the internet as well as traffic, just intra-company traffic. A medium-sized company is going to start to get to 200,000 to 300,000 flows, and our large customers where we have multiple boxes chained together in our enterprise cluster support up to 3.5 million flows. Yes.
You mentioned cascading flow, and it had layer 7 information in it.
Yes.
Where does that layer 7 information come from?
We do regular expression matching, DPI.
Okay.
IP fix you mentioned.
Yes.
Is that something that's going to be rolled back in older devices, you think, or is that a new, moving forward standard?
So it's a software upgrade. So you can take your old Cisco router and upgrade to the latest iOS, which we haven't really actually seen any deployments yet calling for IP fix, but the format is identical, so we may not hear about it yet. But the format is pretty much identical to V9, just the addition of additional fields. And some of those fields we're not actually paying attention to because we get all the information we already need from what we have.
Would that be something like a mid for, besides your tool, you mentioned proprietary fields or custom fields for a vendor, they would need to release a mid type device. Here are these fields you're also getting to look at.
So the ITF has a registry. They put up a registry just like IANA has got all their protocol numbers and so on. They have a registry for if a vendor wants to come out and say, we're going to define these brand new fields and they are this identifier number. You can do proprietary. There is a mechanism to do proprietary ones that you don't have to publish to anybody. It's still pretty new. I mean, there are lots of fields out there. I haven't been following it too closely. Mostly, I think people are using it for kind of custom purposes that are not for, we're going for network visibility. And once you get, one of the big challenges that we face in Profiler all the time is there's all these fancy new metrics we could store and we could put in our product. But for every new metric, you add that times 3.5 million flows and your data retention goes down. So we're very careful about what metrics we want to pull in, and that's why, by and large, all of these new fields, we may pull some of them in on a case-by-case basis, but it's always a big issue.
Thank you.
Yeah.
Is there a way to know which side initiated the conversation using NetFlow?
Not using NetFlow. That was one of the key additions of our sensor. If you'll recall, one of the fields that NetFlow sends us is a bit mask of the TCP flag that's off. Unfortunately, it can't distinguish between a SYN and a SYN-ACK, because if you saw 15 packets, one SYN and a bunch of ACKs, that looks like a SYN-ACK. So that's one of the things we added to our sensor, was we keep track of who the client server was based upon seeing the SYN flag. So it's something that was requested, and we talked to Cisco about it in the past, and they probably have it on their roadmap somewhere, but we haven't seen it yet.
And have you found a way to do the same thing but with UDP?
We have not. We haven't. No, we have heuristics that if we can't tell, if we don't have the sensor in place or the UDP, we have heuristics in place to look at the server port. The client port is some browser number 47,000, and the other port is 53. Well, you pretty much know what that is. And then we also keep track of, in cases where we over time learn that, because we have some layer 7 visibility, this port looks to be a server more often than not. We'll keep track of that. So we have heuristics in place, but yeah, with UDP, it does get tricky. And it would be nice to say, well, just look at the timestamp, where the flow started and timestamp first, but timestamps are unfortunately not reliable enough for that purpose, particularly across multiple routers. Yes.
So some of the newest Cisco gear moved the cache engine out of the router itself and basically says it's external now. They're calling it NetFlow Lite. Do you have any thoughts as to what on earth they're thinking? Like, what are they trying to do?
I'm unfamiliar with that. My guess would be they're trying to offload the processing because they have had problems. Certain routers you turn on NetFlow, and it'll kill the box. This tends to be the older boxes, so they're probably trying to offload it. And then also, V9, generating V9 records, actually that's one thing I can pull up here. So this is what, let me quickly go. This is what a typical V5 record looks like. So you can see the header. Cisco is going to show up as, and one thing that's interesting is NetFlow does not have a standard in terms of port number. It pretty typically goes to port 2055. So here's our version information, some timestamp information, and then we've got our PUs. And this particular one has got 29 flow records in it. And here's the flow record, source and test address and flag tuple. And then if we go down. Got some V9 records in here as well. So I was going to say, so V9 records are much more complicated, both to process and to generate. And so it wouldn't surprise me if they're doing that to further offload. V5 was nice and simple. 6 data size, you can pre-allocate your memory, and it's just array offsets to increment bytes and packets. It can be done very fast. V9, it's got templating, so you can change the order or what fields you want, and it just gets a lot more messy. So for example, now we've got these flow sets, flow set 1 and flow 1, here's all the data. And it looks very similar. And this looks just like a V5 record, but what fields show up here in the data packet are variable. And find one of these. So this is actually the template definition. So if we take a look at here, flow set 1, this is no longer actually data, but this is instead the router periodically has to send us a template to say, I'm going to send you records that have this template, that have this format. So field 0 is going to be the source address, and it's 4 bytes long. Field 1 is going to be the destination address, and so on. So they actually have to tell us, we're going to send you 29 fields, and here's the order of the fields, here's the size of the field, and here's what they mean. All that just adds to the CPU processing. So that would be my guess. All right. Yes.
Just, is regards to versioning and version 3 or version 5 and version 9, does the collector somehow adapt the fields or something like that, or what happens? Is the collector dealing with like legacy switches versus something that's provisioned for the time?
Right, so in, you have to explicitly code for each one. So Profiler supports all these versions, and we normalize it all to our own internal record format. So they pretty much all tell us the same thing. And, you know, once we got the ingress and egress, we expanded our format to keep track of both counters in ingress and egress, even though NetFlow 5 doesn't really support it. So we're only getting a NetFlow 5 feed. We won't have that portion filled in. But
It's empty field.
it'll be empty fields, yeah.
So
So,
it's agnostic to the versions.
yeah.
Okay.
How do you normalize something like S-flow to the
S-flow is a pain. So it's coming up a little bit because NetFlow actually supports sample NetFlow as well, in which case you get exactly the same information, except there's an additional field that says this is sampled at a rate of 1 in 1,000 or 1 in 2,000. So it works just fine if you're only monitoring one interface, because you can extrapolate, particularly if you're talking about, you know, got a gigabit link and I'm sampling at 1 in 1,000. You really probably don't care about counting every single connection. And 1 in 1,000 or 1 in 10,000 is going to be enough for you to see that, wow, 480 is consuming most of this traffic. The problem is when you try to combine anything sampled with anything non-sampled in the way we aggregate flow records. So S-flow, if you're just looking at one S-flow device and that's reporting to Profiler and you want to run all your graphs, it works just fine. As soon as you try to combine that, your timing is all off. And you know, S-flow is going to tell you this one connection, and it's going to not tell you about the 999 other connections that the router did tell you about. So you can still get valuable information, but in general, we tell people don't do sampling. You know, it's just going to mess with your mind. All right, very good. Thanks, everybody.